Hello guys, welcome back. So here we have another question on communication systems from GATE EC 2022. Let h of x denote the entropy of a discrete random variable x, taking k possible distinct real values. Which of the following statement is or necessarily true? H of x is less than or equal to log 2k bits. H of x is less than or equal to h of 2x. H of x is less than or equal to h of x square. And h of x is less than or equal to h of 2 power x. Okay, so what they have given, x is a random variable and it takes k possible distinct values. So let's say it takes values x1 to xk. And similarly, these have probabilities p1, p2 to pk, right? Such that the sum of I equal to 1 to k is equal to 1. So now what is entropy? So we already said in the previous video that amount of information I is given as I of a message with probability p is given as log 2 1 by p bits, and we define the entropy h of the random variable x as a summation of pi log pi, where again I runs from for all the discrete values, right? So here again what will be your entropy? So h of x will be I equal to 1 to k pi log pi. So let us take one simple example just to understand what this entropy means. Okay, so let us take the case of coin toss. So head and tail, and let's say the probability of head in case 1 and probability of tail. So probability of head is 1 and probability of tail is 0. Then what does it say? So every time you are gonna get head. So this means that there is literally no information conveyed, because you already know every time if it is going to be head, you know that it is gonna be head. There is no information conveyed. On the other extreme, if you have case 2, if you have ph and pt both equal to half, so 50% of the time it will be head and 50% of the time it will be tail, and we can say more information is conveyed. So with each toss we can say that the information conveyed is more. On the other hand, if you take an intermediate case, so let's say head is some 3 by 4 and tail is some 1 by 4. So here also you can guess that most of the time it is gonna be head. It is head. But still there is some probability of it being tail. So there is still information conveyed, but it is less than the case 2 case, right? But less than case 2. So here by information we say the randomness of the data. How random is the data? How random is the data? So in the first case, if it is given pH is 1 and PT is 0, you know that every time it is going to be head, right? So there is no element of surprise. So there is no randomness in the data. In the second case, you know only the probability that it is 50-50%, but on each trial you are still unsure what it is going to be, right? And the data is going to be most random in this case. And in the third case, you know that head is going to be higher probability than tail. So at every instant you can expect head as the most probable event. So here the element of surprise is still lower than what it is here, right? And this is called as equiprobable, because the probabilities are equal. So even using this, if you have to plot your entropy h of x for this event, this is either your pH or pt, you will observe that it will have a bell-shaped curve. So this is from 0 to 1 and it has a max at half, and this value is 1. So this is for a random variable x taking two values, head or tail. But here in our question it is taking k values. So for k values, h of x will be maximum when pi's are equal to 1 by k for all I, right? And for this case, what will be your h max of x? So this is nothing but summation 1 over k log of 1 over k, summation I equal to 1 to k, right? So this everything is equal. So this into k will cancel this k. So you will just be left with minus log of 1 over k, which is nothing but log k. And the base is 2, so it is bits. So log 2k bits is the maximum. So your h of x is always less than or equal to your log 2 of k bit. So even here at 0, if you observe, it is nothing but 0 into log 2 0 plus 1 into log 2 1. So log 2 1 is 0. So this term is 0. To find this term, you have to actually take the limit x tends to 0, x log x. So this limit is nothing but, you can write this as log x by 1 by x. So we can use the L'Hopital rule and we'll have 1 by x by minus 1 by x square. So if you cancel, it will be minus x, so which is equal to 0. So this term also tends to 0, and 0 plus 0 is 0. Similarly, on the other extreme also, it's going to be 0. So this is your maximum. So if you go back to your options, so this is going to be true, and it is necessarily true. So second option, if you see h of x is less than or equal to h of 2x. So what it means? So h of 2x is nothing but, if you have a random variable y equal to 2x, if you get the distribution of y, and then if you take h of y, and you also have x, you take h of x, then you compare these both, then you have to say the relation. And you should also remember that h of x and h of y depends only on the probability distribution. So if x and y have the same distribution, then your h of x is going to be equal to h of y. So here we said x as x1 to xk is the values it can take, and with probabilities p1 to pk. Now you are transforming it to y equal to 2x. So what are the values y can take? It can take 2x1, 2x2 to 2xk. And what is the probability? Probability is going to remain same because it is an 1-to-1 map. So probability is going to remain same. So probability distribution of y is same. Only the values change, but your entropy doesn't consider what value it takes. It only is concerned about the probability distribution. So your h of y, which is nothing but h of 2x, is equal to h of x. So this is a stronger constraint. In the question, if you have seen, they are given less than or equal to, which is still correct statement, right? Because the equal to is still coming. So this is correct. So next, the third one, h of x is less than or equal to h of x square. So here you have to be careful. So here I am defining, let's say y2 equal to x square. So now x, let's say takes values x1 to xk, and the probability is p1 to pk. So now what are these x1, x2? If you see here, they are real values. Real means it can be positive and negative. So if I consider y equal to x square, then my x1 square to xk square. So these are all only positive, right? And if I have an example such that this has minus 1 and plus 1 both. So here both will be mapped to the same value of plus 1, right? So then its probability will be some pi1 plus pi2. It will increase. So the distribution is no longer same. So which means that your h of y is not related to h of x square, and x is not related to h of x square. But will it be more or less? Here if you see, we are combining the probabilities. Whenever you take any distribution and you combine the probability, what you're doing inherently, you're saying that the probability of occurrence of this event is going to be increased, which in turn decreases my uncertainty about that event, which means that your entropy is also going to decrease. So your entropy decreases when we combine the probabilities. So this you can give a thought about it and also try to prove it. So your h of x square is always less than your h of x, and it can also be equal to, because in certain cases if this is all positive, then there is a possibility that both the distribution are same and it can be equal. Okay, so is that what the option says? The option says the otherwise, so this is wrong. And the final one, h of x less than or equal to h of 2 power x. In this case what we have, you have, let's say, y3 equal to 2 power x. So is this a one-to-one mapping? Yes, it is a one-to-one mapping. So it is similar to our 2x case. So here also the distribution is gonna be same. So your h of 2 power x is equal to h of x, and if there is less than or equal to also, it is the same case. So it still contains that equal to sign, so we have to go with the option.